All right, it is 11:30, I think. So I'm going to get started. Hello, everybody. Thanks for coming to the SCRAM talk today. It's going to be as interactive as you want it to be. We're going to have a demo. You're welcome to follow along with the demo if you'd like. If you got Docker on your computer, we'll have instructions. If you just want to watch, that's cool as well. But anyway, I'm here to talk about SCRAM, which is the Security Catch and Release Automation Manager. Like all good software projects, we started with the name and worked backwards. I'm Chris Cummings. I clean up messes at ESnet, and yeah, I'm excited to be here. So, like I said, there's a demo capability here. So you can run these commands. If you don't want to have to type a bunch of commands, you can just scan the QR code with your phone, and I have those in a doc so you can copy and paste. I'll give folks a sec to scan that if they want, and or copy down the commands. And if you are going to follow along with Docker on your machine, do the clone and all that now so that you have all the images building and in the background. A little background about ESnet. So ESnet, we describe ourselves as the DOE's data circulatory system. So supporting Department of Energy scientific research and interconnecting all the national laboratories and basically providing like a big fast network so that, global research collaborations, like anything in the high energy particle physics space, DOE interests, the larger internet, cloud, et cetera, all connecting together. So being that, and we consider ourselves like the stage for global science and the laboratory of DOE's big team science. And so trying to do scientific progress that's just completely unconstrained by the physical aspects of things provided by a network and accelerate that science through faster networking. But we don't want all of the internet's traffic, even though we are a very fast internet network. We want to be able to block bad actors, black hole traffic as close to the edge as possible, redirect suspicious traffic for further analysis, disable compromised hosts, and things of that sort. And as you can see, this is our traffic volume year over year. We have a lot of traffic. And so you have to be very cautious about how you filter that. You can't just put a FortiGate firewall in the middle of, ESnet and say, okay, cool, we'll block things. Our standard link size is 400 gigabits per second. And you can't really do that with a lot of firewalls. So worked on a tool called SCRAM. And SCRAM, like I mentioned, stands for the Security Catch and Release Automation Manager. And effectively, it's a modular tool for automating security responses to some sort of security incident of some kind. Basically, in short, it's a web-based service that helps you automate your security data, which is nice and vague by design. But effectively, we can take a user-defined action on IP ranges provided by an engineer or automated tooling, and then do stuff with that. Built on Docker Compose, so you can run it on your laptop for learning, development, modifications, and you can also run in production and have all the nice benefits of running a Docker application. And did I mention it's free? So free open source software. Dop and Sam and Vlad Grigrescu, who used to work at ESnet, really involved in the early days and worked very hard to make this free and open source and get it through all the patent offices and stuff. So it's free to use, distributed under, I believe, a Berkeley license because Berkeley Lab. So what are our use cases? DDoS attack mitigation is a big one, right? So if you have like a DDoS against your network infrastructure, being able to block that all the way out at the edge versus like once the traffic's already saturated your network is really important. Automated threat response. So using tools like Zeek to identify, the evil bit being set in a packet and then actually block that malicious traffic automatically without human intervention and basically in real time. You see a port scan that's, plumbing up your logs, block it right away. So we do temporary blocking, which I just mentioned. So like implementing like a temporary block for a bad IP, allowing you to then go and review that, kind of adjust how long you want to block it for. Maybe you want to block it forever, who knows? And then one thing that we have wanted to do with this tool for a long time is traffic shunting. So, if you have a high volume attack, redirect that traffic, around your critical infrastructure, but you can still use, your analysis tools on it and take a look at it or, forensics later. So some of the features of SCRAM, I promise I'll get to technical stuff here soon. It's built around RBAC so that, you can have multiple, levels of user access. Maybe you have your NOC who just wants to go and say, hey, did somebody block this IP on our network because we can't get to it? But you don't want them to be able to just like go and type in things and block a bunch of stuff willy-nilly. So you can give them read-only access. But a security engineer, they're going to be wanting to actually block subnets and individual addresses and things like that. It's scalable. You can run multiple instances. I think we're running like 6 or so instances right now, just in every single data center that we have, like compute style data centers, not POPs. And they're synchronized. The state, they share basically through a database, and we put a block in one location and it spreads across everywhere. It's real flexible. It works both in the LAN and WAN environments. So we have 2 instances that are dedicated to our WAN network, and basically they are the WAN side we use is like a really big hammer of trying to block, traffic, but that blocks it for all of our customers. So you got to be cautious of that. On the LAN side, we do automated blocking through things like Zeek, right? So you can kind of use it in various locations in your network for different use cases. It's a simple web interface, which we'll get to. It's got an API, of course, so that you can automatically do things with it, and it's extensible. So, right now we just advertise, traffic that we want blocked via BGP, but it's a custom Python module that you can kind of modify to do whatever you want. So if you wanted it to just, instead of blocking via BGP, like make an API call to put in a firewall rule, there's nothing stopping you from doing that. It's all like a really distributed message architecture that's kind of nifty. All right, so a little bit about the components. It's built on Django, which is a popular Python web framework. We use Postgres for the database. We specifically use Cloud SQL through Google Cloud. That allows us to kind of not have to worry about running a highly available database and have access from all of our data centers. We can outsource that and build in redundancy, of course, in that cloud system. But you can run it on your own infrastructure as well, which is how we do it locally on our laptops. Nginx for the web server and static assets and reverse proxy so that you're not exposing a WSGI to everybody in the organization. Redis is kind of how we do a distributed message architecture. And then GoBGP is like the network component. That's kind of interesting. And that actually, we hit its API and then we tell it to tell the network what to do over BGP, which is really extensible. And right now we're just using regular BGP v6 address families, but we're planning to extend to like BGP's VPN v4, v6 address families so that you can do more intricate blocking within like layer 3 VPNs, and hopefully eventually flow spec to be able to put in more complicated block rules into your network. And the translator is this module that I mentioned that basically takes all this data from SCRAM, the Django application, and sends it to GoBGP to make it real on your network. But you could also write a translator module that sends it via carrier pigeon, or just sends DOP a phone call and says, hey, DOP, can you go block this? We, of course, love to integrate it with Zeek. So there is a Zeek SCRAM package, which you can just ZKG install. There you go. And the general flow is that Zeek detects bad things. We decide what we want blocked and send it to notice.log. And then Zeek uses the SCRAM client to actually block either temporarily or permanently in the entire network. So a kind of flow of how that works is traffic comes in, it hits Zeek. Zeek does its magic. Is the evil bit set? Yes. Is it not? No. If it's not set, obviously we're not going to block it. But if it is, Zeek goes and using the notice framework, it adds that information to what's called the SCRAM client, which then basically caches that and holds on to it and tries to basically batch those out to the SCRAM. And if SCRAM is working, obviously it's going to send it out. If for whatever reason the SCRAM instance is offline, it'll wait and hold on to that so we don't miss blocks in case of like upgrading the application. All right. So in Zeek, it's actually straightforward. You just pop this, and a lot of this is actually optional, into your local.zeek file after you've added via whatever management framework you're using for Zeek, the actual SCRAM Zeek package, and you're good to go. You also have to install the SCRAM client in your Zeek instances so that it can talk to the appropriate SCRAM service. Okay. Demo time. Is anybody going to follow along? Okay, you're following along. Were you able to run some commands and pull things, or are you going to wait? Sweet. Cool. So yeah, the demo environment, we have SCRAM running, which has a bunch of containers, specifically, all of the ones I mentioned that support the SCRAM application. But we also added, I was inspired on Monday by the Zeek workshop to add a Zeek container. And so this Zeek container is set up automatically to basically connect to SCRAM, automatically register itself as something that wants to, talk to SCRAM and block things. And so the demo flow is going to be start up the stack, go into SCRAM and approve the Zeek client that's tried to register and give it authorization to be able to do what it needs to do. And then we'll actually run some traffic through Zeek and watch it block it in SCRAM in the web interface. Now, I don't have it plumbed up to a real network. I didn't have time to make that happen. So we can't actually show you the traffic being blocked. You'll just have to trust me that BGP works. So again, here are the commands and a QR code to the text instructions. And I'm going to now leave slide mode and go here. Is that text big enough for folks? Would you like a little bigger? All right, cool. So first things first, of course, I'm going to see the instructions. We're going to clone the repo. I'm going to do it live. So I'm cloning the specific branch of SCRAM for this demo, which, yay, easy to do. We'll go into the SCRAM folder. You can see that we're on the branch. And we're just going to run basically a little helper command that toggles it from production mode by default into local mode. And that configures basically the repository such that it can run on your laptop and, you know, kind of hard code some stuff that you would have to configure if you were doing this in production. If you run that, it's just a symlink. And the next step, Zoom controls, is just literally start the stack. So if you haven't built the images before, this takes a bit. It has to download stuff, dependencies, and actually do Docker build. I already run the build here, so you don't have to wait. So it's just starting all the containers. And if you're not familiar with Docker Compose, it's pretty useful because you can define dependencies between your applications. So in our Compose file, we, bring up the database first before trying to bring up the web application. And then in this one, we wait to bring Zeek online, of course, until until Django and SCRAM is actually working. So we're waiting for that to go. Some of the containers are starting to get healthy, and it just takes some time. So once these start, I'm just going to run another little helper command because we use random ports to run it so that you can run multiple instances locally. Just running a command that'll help me open up the web page. Yes. No, go for it. Okay, we'll wait. So I'm going to run make Django open. Let's go open my little web browser. It automatically generates a admin password for us, which is now gone. But if I go to the admin page, remember that I have the Zeek container set up and ready to try to start blocking things in SCRAM. So the SCRAM client has a function built in to actually register automatically to SCRAM. And now it's not going to authorize itself because that would be really scary if you could just authorize yourself to block things on the network. But it will basically make a request, and we go into the administrative page of SCRAM, and we just go to our clients here, and you can see that this one tried to register. And I'll show you basically like the logs showing this happen. And this was set up to kind of automatically start for a demo. So this is not exactly how you'd run it in production, obviously. But if I look at the Zeek containers logs, which is running everything, you can see that its config file is like, oh, it didn't find a valid UUID. So we are actually going to talk to the SCRAM instance that it's been pre-configured to talk to and try to register itself. And basically each client gets a UUID that it uses for authentication and all that fun stuff. So I go into my Django administration page, and now I see a client has registered, which this is the host name of the container, which, Docker containers. There's that UUID that we saw. So now I'm just going to toggle it from unauthorized to authorized, and I'm going to select the actions that it's allowed to do. In this instance, we only have block set up because we don't have any other actions we want to do. So save this, make that modification of the database, and we should now be good to go to actually block stuff. Now, I'm going to pause here and give you a quick tour of the SCRAM UI. It's really simple. There's not a lot to it. This is the main page. Here, you can see basically the ability to put in an entry. That can either be an IP address, of course, IPv4 and v6, a CIDR range. So you could say like block this entire /24 of IPv4 space, or the /32 from this organization that has been attacking us. Then you select your action. You put a nice little human readable comment in there so you know why somebody chose to block this. And then you can optionally set an expiration time. And now one of the cool things about SCRAM is that we're of the opinion that just because you see malicious traffic from an IP address once does not mean it's always a bad IP address. And if you were to block every IP that ever tried to do a port scan on you, you're going to end up permanently blocking a ton of the internet. So instead, we just basically set default expiration timers on our automatic blocks. That way it can age out. And if Zeek detects bad things happening again, well, we'll just block it again. But you can also, set this to never expire and have it be a permanent block. And then you'd click add entry and then it goes. So just for the demo, I can show you, we'll block 2001 DB8 ::1 /128, say test what demo. And I'm not going to bother setting an expiration because I want to always block that IP. I hit add entry, and now you can see that localhost, which is just the SCRAM instance running, has blocked that IP address. Now, when you have multiple SCRAM instances running, that from localhost is very useful because you can see, oh, this was blocked in our East Coast data center. This was blocked by our West Coast data center. And you can kind of get a little bit more granularity there. I'm going to pause for a sip. All right. So now over in the Zeek container, we're going to run basically just a script that's going to do TCP replay on a bunch of bad packets. And these are just the PCAP files that are included in the Zeek demo. So if you were at the Zeek training on Monday, it's pretty much a stock version of that. I did renumber the IP addresses to make them look a little bit more interesting, but other than that. So I even included a make target to do that. So if I just do make Zeek packet generator, it's going to run through all those PCAPs and send them through. And now we're going to go over here to SCRAM. And we see that something got blocked. So Zeek saw that there was, a port scan basically from here. And we don't currently like bubble up the reason why it was blocked, but you can go in here. And when you go to the entries page, you can see that this one is actually set to never expire, right? 999. Well, if I'm still working at ESnet, then I have other problems. But here, this one was set to auto expire in, I think, like, I don't know, half an hour. Anyway, I don't know how to do math. But yeah, so there's the entry. And if for whatever reason, Zeek went off and did something we really didn't want it to do, I can just go and deactivate it manually, and now it's no longer blocked. So that's kind of the demo. I really blew through that. But I wanted to just really give time for people to ask questions, talk about it, see what they think about it. Throwing up some links here to the actual repos involved. The humans involved in the project are myself, Dop, and Sam, who's not here physically with us today. And yeah, okay. Yeah. Mm-hmm. Yeah, that's a good question. So right now we don't expose that in the web UI, but the way that we make it work internally is that we never actually delete an entry. So anytime a block has been performed, it is always in the database. And if we ever try to reblock that IP again, it's effectively reactivating that entry in the database and setting a new expiration time on it. So we haven't exposed that in the UI. I believe the API does have a way to search that, which is more important. And then traditionally, we use logs to kind of do that. So we syslog every time we take an action on the network, of course, and then that goes to our Splunk instance and can be searched and all that stuff. So that's kind of how we're handling it now. But yeah, I think honestly, we want to spend a lot more time putting some love and energy into the web UI and making it more useful. But really, for us, the minimum product needed was an API to do this, because as part of the ESnet 6 project, where we kind of revamped our entire network and did a big overhaul, one of our big deliverables was the ability to do automated blocking in the network. And you're probably familiar with the old BHR project that uses like ExaBGP and was made at ESA. Yeah. So this is very similar. It's basically like a modernized version of that in a lot of ways, but with some different architectural decisions. Go for it, Kay. Yeah. One of the big questions that we've gotten when talking to other people running BHR is, what if I want to keep my history? can I import that into SCRAM? And we don't have a tool to do that, but it would be pretty straightforward, I think, to write something to do that if you cared about it. I would probably not recommend going down that path. Just keep it separate. Don't bring the craft forward. But I know that for a lot of people, it is important to keep blocking things that they have blocked once and to do that forever. And so if that was important to you, it would be possible to migrate that just using Django's really friendly ORM scripting language. Other than that, I would say one of the main differences is how the synchronization works. The synchronization on SCRAM works by the instances sharing access to a Postgres database versus I believe BHR kind of uses the API to exchange information between instances. And I know that that can be sometimes a little maybe failure prone. So using a database and just like letting the databases do distribution of data, like that's what a distributed database is really good at. Consistent distribution of data. So we didn't want to have to write that ourselves, so we just use a database. So that's like another thing to keep in mind. We really heavily recommend you run this in a containerized environment, which I know you can do with BHR. There's nothing stopping you, but for folks running BHR, that might be a learning curve. So getting used to Docker Compose and like how logging works in a containerized environment is, quite different. And so those would be kind of the main things that I think, as we've talked to BHR users, we've probably kind of run into. Yeah. So the question is, we've got some examples on how to integrate with Zeek. Could you integrate with other things? The answer is definitely you could. It's a REST API. It's very straightforward. So, and there is the SCRAM client, which is not specific to Zeek. So the SCRAM client's real simple. It's just a CLI. And effectively, you just send a standard in to the application, basically 5 lines, IP address, a note, an expiration time, some other stuff that I don't remember off the top of my head. So you could very easily use the SCRAM client to do so. You could also just interact with the API itself because it is straightforward. Let me go really off script here and I think it's /v1/API. No, I don't remember. Trailing slash is my favorite. No, API/v1. There we go. We can try all permutations. Aha. So we're using the Django REST framework. So Django REST framework is very straightforward. And it's actually cool because it has this little, it's almost like Postman, if you're familiar with that, but built into the web page where you can actually play with the API. And so here you can see this is just the actual root of the API, and this tells us which paths we can go to. So we can look to see who the users are, what actions are available to us. We can hit the register client endpoint, which is what Zeek did at the beginning of the demo to actually, register itself as an authorized endpoint to make changes. You can actually see the entries themselves. And we also have this concept of ignore entries, which I guess I didn't go into, but ignore entries is really important because if you have some hosts that maybe you don't want to block ever on accident, if something goes haywire, you can add to that list, and SCRAM, even if somebody tells it to block things, will refuse to do so, and it will return the appropriate error code to you. But yeah, so to answer your question there, Josh, it's like, if you wanted to integrate, really all you have to do is go to the entries API endpoint and be able to put in 4 fields. So any tool that you wanted it to do to send to an API, super possible. And if you didn't even want to interact with API, if you can output custom text to standard out and redirect that into SCRAM client, you're set. So I would say it's pretty extensible. Yeah, I'm not sure why it must have timed out already. So if I replay the packets, I think it will tell me why we blocked. No, why does that not show up there? Yeah, but so like usually the way we do it is we'll put like the Zeek module that actually registered the notice. So like scan, : whatever. Yeah, if I go. Yeah, so here's the one where we blocked it, and you should see the comment was scan, port scan, and this is like the actually way more detailed view of why you actually blocked things. And dot maybe like the in 0 minutes 0 seconds, that's from Zeek, right? Where it tells you how long it took. Yeah. Yeah. So that's the cool thing is that like, if you're already running Zeek, anything that you send to notice.log, you can turn that into SCRAM. And then in the SCRAM Zeek config, basically right here is where you define the types that you want to block on. So it's not necessarily going to automatically just block anything in notice.log, but anything in notice.log that matches these block types is then able to be, acted upon. And one thing that I've, talked about a little bit, but haven't shown is that the idea of SCRAM is to be very extensible. So right now, by default, we just include block because that's kind of the big one. But if you wanted to make any other type of action, it's extensible to do so. And the Zeek config would also be extensible to do so. So you could say, redirect types. And perhaps when you see like failed SSH attempts, perhaps you want to redirect that to an analysis node that does a full packet capture that holds on to forever versus just your Zeek logs. So that's kind of some functionality that we're hoping to extend more in the future. And we've built it with that in mind. So that's another way that it's like kind of different from BHR is that it's meant to do a lot more security automation tooling than just blocking stuff. And I briefly mentioned this, but if you have any students who want to work in our student program, I'm kind of soliciting people who are interested in BGP to come maybe work on this with us. But working on BGP flow spec, which if you're not familiar with, is a really powerful and dangerous, but powerful tool that allows you to use BGP and the flow spec address family to distribute effectively access control lists through your network. And so eventually being able to get to the point where we are right now is if a customer calls us and says, hey, we're under attack, can you block this? This is a manual action because if we block it, we're blocking it on the entire network. And we don't want to run the risk of, customer A saying, hey, can you block this? And customer B being like, no, we actually really need to get to that. So it's a very like purposefully slow and manual process because we don't have granularity. Going back to FlowSpec, with FlowSpec, you do have that granularity. So I could get a phone call from a customer who says, hey, we're experiencing high volume of NTP traffic from this autonomous system number to our autonomous system. Can you block just the UDP 123 NTP traffic? And with FlowSpec, you have the granularity to be able to do that. So once we get the FlowSpec parts, kind of figured out, and of course, how to prevent foot gunning ourselves by accidentally doing what CenturyLink did and blocking, TCP 179, which was BGP, and then everything went down, and then they had to physically roll trucks to every site, and nobody wants to do that. So once we figure that part out, we would love to extend SCRAM so that you could then put in, 5 tuples and actually block things at the edge of the network where we have greatest capacity, right? And prevent it from coming in, but only to specific destinations, which will be really powerful. So the tool is built with that in mind. Any other questions? Chris? So to unblock, we just deactivate the entry. So it's not specifically an action because we do not block by default everything in our network, right? We allow everything by default. So we're only enacting blocks. And then if you want that block to go away, you deactivate it. Sure. Yes. I believe that we can send an HTTP delete to the entries endpoint for the endpoint that you want to deactivate. So yes, it's capable of undoing what it did. Yeah. Yeah, and that's a great point, and I guess I'll repeat for anybody remote. The question is here is like, how can we kind of be more granular about blocking and unblocking and permissions? If that's an okay summary. Okay. with the RBAC system, it is very possible to allow very granular roles past just read only and read write. With Django, you can put on any function that gets run, basically, I'm hand waving here, but on any function that gets run, you can do authorization checks. And so really any type of granular access control in RBAC that you want to do is possible in the Django framework. So that's a great question. Thank you. Okay. Yeah, the question is, what kind of support do we provide? This software is provided without warranty under PSC. So yeah, we can't actually do it for you. We can't run an instance for you. We would love to talk to you. We would love to help you. Scott Campbell, who is formerly with ESnet, has spent a lot of time working with a few organizations on trying to get it to work in more unique containerized environments than just Docker. And so we're willing to put effort into that. It's one of those things where we can't like promise you we're gonna like solve all your problems, but I know, at least for myself, I kind of just enjoy working on the project. And so like if you come to me saying like, hi, I want to use this, but I'm running into this problem, like if you're trying to work on it, like I'll absolutely help you. And Dop will actually answer your phone calls at 2 a.m., by the way, if you ever want to. He's just nodded his head yes. You can't see it on camera. Chris. Hmm. Yeah, good question. So I'll repeat that. The question is, with the do not block list, is there a way to override that in case of a really big incident of some sort? BHR supports that. We do not support that currently. It would definitely be possible to do. And then again, you could apply granular RBAC, which would be like maybe only a subset of the security team is allowed to actually approve that or things like that. So yeah, it's very extensible. And I would like to add too that like if we're kind of at the point where we've been running it now for 4 years, I think 3 years. Anyway, a while. It's stable and it works. And so now we're at the point where we're wanting to reach out and kind of build a bit of a community around this and help people do so. So hearing use cases like that is incredibly useful for us because, especially at ESnet, like we have our way of doing things, right? And it makes a lot of sense to us. And we have a very limited scope of a very fast network that does exactly one thing. When you start going out to campuses and computing facilities, all these intriguing use cases come up that we never would have thought up on our own. So we're totally like down to hear that and help implement that stuff. And the cool thing is it's an open source project. And so like if you see a feature you want to add and you started using it, you're very welcome. I'm not saying pure is welcome, but you're very welcome to actually work on the code. It's all out in the clear. We even do our project management for the actual project within GitHub projects, their little Jira knockoff that they have. So yeah, go for it. Mm-hmm. Mm-hmm. Yeah, the question is how to yeah, the question is how to handle Postgres database growth. It's sometimes an issue with BHR. So for us, it's easy because we're using Cloud SQL. The only database growth problem we run into is funding because Google will happily charge us as much. I can say that our database is about, I think, 500 megabytes on disk when I do like a SQL dump. And that's with all the overhead of Django's tables and all that stuff. And that's with 3 to 4 years of history living along in there. So I will say that it's not been a problem. Um, it's also straightforward enough that you could definitely write a script to start pruning entries older than a certain age. And then, maybe if you don't care about entries from 20 years ago, just get out of them. But the good news is like Django is super scalable. So like Django works really well on large data sets when the tables are designed well. And so it's I like our use case is like when it comes down to the database, there's like, 5 tables. Each one has like 5 columns. It's not, built to grow massively. It's not like going to grow massively. And Django, there's, I mean, popular websites and stuff based off the Django framework that have, terabyte sized databases and stuff like that. So yeah, good question. Anybody else? Mm-hmm. Yeah, so that's a good question. The question is, can you do effectively like an exponential back off of your blocks, right? Where you would, block for 30 seconds the first time, block for 60 the next time, 120, et cetera. So SCRAM is not set up to do that by default in any way, but you get to specify what the block time is. And so it would be very, and I'm not sure if this is a Zeek feature because I actually had never installed Zeek until Monday. um, but it like I'm not sure if Zeek is capable of doing that, but like if you were using like fail to ban or something, and like you wanted to take fail to ban logs, and then like you could have a command that like watches fail to ban logs and takes the fail to ban timer, and then parses that out into the 5 lines required from the SCRAM client, and then puts that into SCRAM. You could use the benefits of a system like that to give you that. And if that was something somebody wanted, because we do keep track of the entries in the database, it would be possible to go, hey, this has been blocked before. Maybe provide feedback to the client who's requesting the block. Maybe you want to do it a little bit more this time. Maybe you want to do it permanently. But I will say that the kind of goal of SCRAM is to keep it a simple tool that can work very much in the Unix philosophy. And that's why like the SCRAM client supports like standard in and standard out as the way of interacting with it, even though I kind of hate doing that. So yeah, great question. Um, for those of you that were actually trying to run along at home, were you able to get it to work? Curious? No? No. Well, if you want to play with it later, I'd be happy to help. Any other questions folks have? Comments, concerns, cries of outrage? Yeah, yeah, slides are available. Here's a QR code. I can also, if you give me a card, I'll email them to you if you don't want to scan stuff. Yeah, Kay asks if she wants to run Python too, can you do it? No, unfortunately not. And by unfortunately, I mean very fortunately. One of the good things about SCRAM that I'm quite proud of is like how modern it's built. And so we have a very like extensive test suite that runs every time you make a change, of course, which is table stakes. But one cool little test we do is we actually test it on the current supported Python version, which since we run in a container is very easy to manage, and the future Python versions. So every time Python releases a new version, it's automatically testing it against that so that we, kind of don't get surprised by Python deprecating stuff and changing stuff. And we don't have to hopefully deal with a Python 2 migration. And is BHR still in Python 2.7? Yeah. So this is not, I think we're running 3.13 in prod, which is we'll leave the name unnamed. And that's somebody, and I did not add Kay's name to the end of the slide, but Kay is also helping us a lot with SCRAM. So it really is a group effort. I'm just up here yapping. But yeah, there's a lot of people within ESnet working on this. So don't worry, it's not just this weirdo that you'd have to talk to if you wanted to run it. Cool. Well, it's the last day of the conference and it's tail end, but Chris, you got another question? Keep them coming. Yes. So I copy and yeah, so the question is, how does the country scaling work in the Z config? So I copy and pasted this from Dop's example. And I know that in the Zeek script, we do use the GeoIP feature that Zeek provides. I don't know what country scaling actually does. That might have been a future feature, but it is entirely optional. You do not have to include it, but I don't know. Dop, do you know? Yeah. Yeah. I'll have to get back to you on that one, but that's a really good question. Mm, yeah. Yeah. I think that assuming that we do country scaling, I don't see why not. But that comes with a massive hand wave disclaimer. Yeah. Minimum block time. Yeah. I believe second. 1 second. yeah, I believe is the minimum amount of block time that you can provide. I'd have to look. I think that the way we do it is we provide it in an expiration date. So you tell SCRAM the date and time you want it to expire versus how far from now. But I could be actually. Let's look at the API. Let's see API root entries. I don't even know why. Yeah, I would have to get back to you on that. I can't remember exactly what we send, and I deleted the container that had my example file that used the SCRAM client to do so. Um, yeah, and I guess I kind of glossed over this, but all of this code is public. So there we go. So like the SCRAM client itself, this is modified very heavily from the HR client. Works very similar. I believe Justin was kind of one of the original folks behind that. So you know it's good. And I was gonna look here to see. I think we have an example text. Yeah. So yeah, you do tell it in seconds. And then I believe in the SCRAM client, we then convert that to the date time value that is expected by the API. So if you were not using the SCRAM client, I believe you'd have to give a date time value. If you're using the SCRAM client, you would give it in seconds. But yeah, I believe it should take 0 even. I'm not sure that might crash the client. Hmm. I believe, yeah. Yeah, I believe, and I rewrote the CLI recently, and so you'd think I'd remember, right? But I believe that it is only in seconds. But I mean, pretty. Yeah, calculate expression time provided in seconds. So yeah, that's how we do it. But the API itself, I mean, is accessible. So really, any format that you wanted to take and transform that, just a little bit of scripting or even just some sed or something could get you pretty much there. And because it works with just piping, you can kind of transform whatever format you want to whatever format you want. Anybody else? Hopefully this was helpful. If not, please let me know. I'd love to change things. Or don't. It's up to you. But yeah, thank you so much for coming. I really appreciate it. And I'll be around.